yeah, oxygen is removed. It's removed. That's start on. Now, another thing here again is there that addition of electricity. That electricity is across, and that's why it's now, also, but and carbon also gain oxygen, and oxygen itself is an electricity. That's the word oxidation can be intense or that's the two parts of now when electrons or electrons change electron loss, there are two things we do for oxidation and reduction. Now, guys, oxidation forms the source of electrons, while reduction involves what? Let's say the source of electrons, you can say that is oxidation. But when there's a loss, when the beginning of electrons, that is reduction, and when there's a loss of electrons, that is that's the process. It takes time. Next time here, electron transfer, the electron transfer. Now you can see from there, that was for application. Let's say analyze that word. From the first you can see giving us zinc 2 plus aqueous plus 2 electrons, and we can see Cu2 plus 2 electrons. And I want to take us what we call oxidation number. Oxidation number. Now, one thing we need to know is that we should be able to determine the oxidation number of various elements. Now, in the sense of now, let's look at the next slide. Let's look at the next slide. Let's look at the next slide. Look at the next slide. Now, for the next slide, you can observe that we are told to determine the oxidation number of the underlying element. The first one is Cl2. The first one is Cl2. Oxidation number of Cl2. Now, Cl2 is neutral compound. And we need to know that the oxidation number of neutral compounds are always what? 0. So the answer to this is what? 0. You can have Cl2, you can have magnesium, neutral compound of elements, you can have O2, you can have H2, they are all 0. They are all 0. The next one is what? HCl. We are told to identify the oxidation number of the underlying element there. And you can see clearly that the underlying element is hydrogen. Hydrogen. So we need to know the oxidation number of hydrogen. But chlorine itself has an oxidation number of -1. So we need to know how do we now know the oxidation number of hydrogen here? Is that the sum of the oxidation number of each corresponding element here must give us 0. So that means H plus Cl is equal to what? 0. And what is the oxidation number of hydrogen? That is the unknown. Chlorine is what? -1 equal to 0. So H is equal to what? +1. That is the oxidation number of hydrogen in HCl. In HCl. I believe that we are following. Although we probably give assignments on things like this, but we need to also pay attention and understand the basics of all this. Because if we don't know how to determine the oxidation number of many elements, then we'll be unable to answer a lot of questions on that part. Now, the next one is Mg2 plus. Mg2 plus. Mg2 plus is an ion. An ion. Now, we have what they call cations and anions. In cations, that are positively charged ions, and anions are negatively charged ions. For example, now, Mg2 plus. What does about Mg2 plus? The answer is Mg is equals to +2. +2. +2. It goes to the other side, turns to +2. It's +2. The next one we have there is NO3 minus. And we are told to determine the oxidation number of nitrogen. Now, how do we do that? Same technique. N plus oxygen, for the number of oxygen is -2. That is N plus open bracket -2 times 3 equals to, some of this, we have a minus there. That means it's equal to -1. So N minus 6 is equal to -1. And N is equal to -1 plus 6. That is equal to +5. You can see the oxidation number of nitrogen there is +5. Is +5. Now, the next one is K2CR2O7. So we have K2CR2O7 and we have KMNO4. We have K2CR2O7 and we have KMNO4. Mn, chromium. Now, we want us to understand something here. And not get swayed with what we know earlier on. But this can look tricky. Now we have K2CR2O7. And we all know that we are going to get the sum of all this first. Now, if I have, that will be the oxidation of group of potassium is a group 1 element. So the oxidation number of all group 1 elements is always a +1. So potassium is +1 times 2 plus 2Cr plus -2 times 7 equals to 0. The sum of will give us 0. Initially, we had NO3 minus. That sum to give us with -1 because the power of all that group there is minus. So this will turn to 2 plus 2Cr minus 14 is equal to 0. So 2Cr minus 14 plus 2 is equal to 0. And 2Cr is equal to -12 is equal to 0. 2Cr minus 0 goes right hand side, turns to 12. And Cr is equal to 12/2. That is +6. Now KMNO4, look at this, KMNO4, KMNO4. It's the same technique. Potassium is +1 plus Mn plus minus 2 times 4 equals to 0. So plus 1 plus mn minus 8 is equal to 0. Mn minus 8 plus 1 is equal to 0. And we can say mn is equal to plus 7. So with that, you've been able to what? To determine the oxidation number of this, of various elements. Now, guys, quickly. Earlier on, when we talk about oxidation and oxidizing agent, we talked about oxidation and reduction. I did mention the fact that we have what we call oxidizing agent and reducing agent. Why? Because I feel that I wanted us to understand the basic concept of everything. Now, in any redox reactions, the oxidizing agent, also known as electron acceptor, and the reducing agent, also known as electron donor, will always exist. Will always exist. And that is why I want us to understand that very, very well. Now, how do we determine them? How do we identify an oxidizing agent or a reducing agent? Oxidizing agent number one, they are electron acceptors. They accept electrons. They accept what? Electrons. Number two, there are substance that is reduced in the process. So when you have a redox reaction, the substance that is reduced is called an oxidizing agent. And lastly, for oxidizing agent, the substance in which the oxidation number decreases is known as the oxidizing agent. So when you have this, you can easily determine the oxidizing agent of that equation there. Now, reducing agent is the opposite. In reducing agent, the substance that is oxidized is called a reducing agent. The substance that is oxidized is called a reducing agent. For reducing agent, the oxidation number is what? Is increased. The other one was decreased, but for reducing agent, it's what? It increases. And lastly, which you need to also note, is the fact that reducing agent, so the substance, fine, we say sometimes is oxidized, but do we also ask ourselves one good question, that how do they become an electron donor or an electron acceptor? That's where we take it, the next question from. That is the next example. So let's see how we can apply such knowledge we know about. It's not about you identifying, it's all about you knowing the elements to identify. Now, if you look at this chemical equation, zinc solid plus copper 2 plus aqueous gives us Cu solid plus zinc 2 plus aqueous. Now, earlier on we said that 0 to plus 2 is what? Oxidation. It has lost 2 electrons. That is loss of electron. That's oxidation. Cu2 plus to copper is reduction. Now, how do we determine the oxidizing agent and the reducing agent? Zinc itself, it had an oxidation number of 0. This is plus 2. 0 plus 2. We can clearly say here from 0 to plus 2, 0 to plus 2, 0 to plus 2, there have been an increase in oxidation number. And such substance can be said to be what? A reducing agent. For copper, Cu2 plus, from plus 2 to 0, there's been what? A decrease in oxidation number, and such substance is said to be what? An oxidizing agent. So these are that technique of knowing it. So you look at the oxidation number, you can easily figure your way out in determining the Ra and the oxidizing agent. And another tactic again is that most all metals are reducing agents. Most of the time, metals are always reducing agents. Also, if you look at we said substance that is oxidized, look at zinc here. From 0 to plus 2, we can clearly say that it was what? It's reduced. You can either make it become what? A reducing agent or an oxidizing agent. So, is the reducing agent here? Zinc is the reducing agent here. It is oxidized, and we can also observe that the substance was what? Reduced for copper. Now, if I now pick another example from what I have there, chromium plus 3 magnesium, giving us chromium 3 plus 3 Ag. Now, chromium to this 0 to plus 3 is what? Oxidation. Magnesium to this, sorry, 3 Ag is 3 Ag plus. So plus 1 to 0 is what? Reduction, red. Now, I want to bring out something, guys. Now, we can use that 0 to plus 3 is what? A reducing agent. And chromium undergoes what? Oxidation, and it is what? Oxidized. And you can also say that it is what? An electron donor, because it moved from 0 to what? To plus 3. It has donated what? 3 electrons. It has donated 3 electrons. Now you have Ag plus from plus 1 to 0. You can clearly say that what has happened there, it has what? Accepted an electron. It has accepted an electron, and you can clearly say that Ag plus undergoes what they call reduction and is reduced in the process. And with that, we're able to determine or identify a reducing agent and an oxidizing agent. And what we need to also know is how to balance chemical reactions. How to balance. Don't forget, we are still in the series of electrochemistry, and I want us to pay attention. But after this class, the next we are going to be talking about electrode potentials. You need to understand the electrode potentials. Placement of groups or atoms. So you need to also pay attention to this. And lastly, electrolysis. Very, very important. You don't miss such part when preparing for a JAMB exam. So you need to pay attention to that very, very topic. And let's not forget, is the series. So maybe 2 classes, then we are through with that series. Then after that class, then we can start another new series on energy and see where we can cover for that part. Now, I'm going to also be giving an assignment on this part too. If you observe, we should be able to know that fine. We now determine an oxidizing agent and reducing agent that is theoretically. We also have the way of determining it lab. You are in the lab, and that's why I'll give an assignment. So before I start the next class, I'll just really talk about it. So the first assignment is test for oxidizing agent and reducing agent. Please, let's not forget to lay our hands on this part. I'll talk about it next class, but let us take this as an assignment. Now, we can go to the next part. Now, I believe we can go to the next part. That question that we have, there's a very popular question in JAM. And most of the times, you may not even be told, you may just be given to determine the coefficient of the balanced chemical equation. And sometimes you might be told to calculate using it. So now, we're going to learn how to just balance today. And later classes, we'll look at how we can also apply it for some certain questions, because you don't miss such questions. A very popular question in JAM. So let's quickly undo that part. Balanced chemical equation can be in 2 medium. It can be in acidic medium, and it can be in what we call basic medium. Now, in acidic medium, simple concept. Acidic medium, adding what? Water. And in that case here, you are adding water and what? And H plus. So when you're adding water, H2O, and H plus, you see that is what? An acidic medium. Straight up. So you need to understand something about this balancing. That there are procedures of balancing. So you don't just rush to balance, because if you rush to balance, you might not even get the answer. And you might have jumped what? Few steps. So I'm here to guide you on how to balance one. Then basic medium. Basic medium, students do say that it is very difficult and stuff like that. It's not difficult, actually. It's the same concept to understand about acidic medium. And what you do in basic medium is that you are adding OH minus ion. OH minus ion. And that is what is very important. OH minus ion, that is what? The ion for what? For base. So H plus for acids. So let's now see how we can apply it for a question. let's consider from what you have on the slide. Let's take that question. Let's take that question. So please pay attention. The first question there is, you can see clearly, we have Fe2 plus, Fe2 plus to Fe3 plus, and MnO4 minus to Mn2 plus. Now, the first thing to do for balancing is to first identify the oxidation half cell equation and the reduction half cell equation. I'm very happy that earlier in the class we talked about something like that. So I have Fe2 plus, I have Fe3 plus. Now from 2 plus to 3 plus, we can clearly say that that is what an increase in oxidation number. An increase in oxidation number. So plus 2 to plus 3. Now we add minus 1. So we did this earlier on today. So magnesium, we need to know the oxidation number of magnesium. This is plus 7. And this is what? Plus 2. Plus 7 to plus 2. Plus 2 to plus 3. Then that's a very good question. What has happened there? We have plus 2 before. They had lost one more. That is what? Plus 3. Sorry. It's yes, lost one more. That is plus 3. And that is, if the oxidation number is also known as oxidation. This is oxidation. This is oxidation. Why this is what? Reduction. Now, we've been able to identify this. We're able to identify this. Now, what do we do next? Is to what? First of all, look at the atoms. Are the atoms balanced? The atoms, excluding the oxygen and hydrogen. Iron is balanced. You have one on the left-hand side, you have one on the right-hand side. Magnesium, you have one on the left-hand side, you have one on the right-hand side. Some composers can come in various ways whereby you have one and you have two of the atoms. What you first do is for you to first balance the atoms. Balance the atom first before you proceed to balance the chemical equation. Now, having checked all the two equations, let us see that it is balanced. Then we can proceed to balancing the electron and hydrogen and oxygen. But here, for the first equation, the oxygen, so we have to first balance the electron. So I have plus 2, I have plus 3 here. For me to make it equal number of electrons, I have to add one electron here, plus E minus. So this is plus 3 minus 1 is plus 2. Right, plus 2, balance. Now for this, what I do first for you is for me to first balance the number of oxygen. Now, guys, pay attention. MnO4 minus, Mn2 plus. Now, I want to balance oxygen. I have oxygen on the right-hand side, left-hand side rather. For me to balance the right-hand side, I will just add 4 moles of H2O. So no matter the amount of oxygen you have on the left-hand side, add it to the what? Right-hand side of that to make it balanced. You have 4 H2O. But in doing that, you have increased the number of hydrogen on the right-hand side. And that is 4 times 2, 8. So you have to add 8H plus here. We've done that. Now, for us to balance it now. But since we have done the balance of all the atoms, we need to balance the electrons. Now, we can clearly see here that the net equation, we now work with net equation for this. Why? Because we have numerous groups here. So numerous ions. So this is minus 1 plus 8. This is plus 7. Why this is plus 2? So what do we do to balance it? Plus 7 plus 2 is to subtract 5 from the left-hand side. So that we add 5 electrons on the left-hand side. And I've done that already. Now you can clearly see from here now, guys, that the first equation, iron plus 1 was added to it. Second equation, we added 5 electrons. Now we want to look for a way to get what they call the net chemical equation. And regarding the net chemical equation, we need to first balance the number of electrons. We have to balance it. And how do we balance? We balance it by the number of electrons. They have to be the same thing. So what do we do? Like what is simultaneous chemical equation? Simultaneous equation, we have to do plus 1 here, 5. We have to multiply this equation 1 by 5, and multiply this one by what? By 1, equation 2. So doing that, we have 5Fe2 plus 5Fe3 plus 5 electrons. While we have 5 electrons plus MnO4 minus plus 8H plus, giving us Mn2 plus 4H2O. So multiply by 1. So what do we do next, guys? Is to add. Let's add. If you add, you observe that 5 electrons left hand side, right hand side, it cancels out. So most of the time, for it to cancel that, they must be in the same, they must be in opposite sides. So if it's not opposite side, you cannot cancel them out. So you can add 5Fe2 plus MnO4 minus plus 8H plus, giving us 5Fe3 plus Mn2 plus 4H2. So guys, this is the balanced chemical equation. Very, very popular question in exams. Now, I want to quickly bring out something to show you something that many people don't really note about. And let's write that out again. 5Fe2 plus MnO4 minus plus 8H plus, giving us 5Fe3 plus Mn2 plus 4H2O. Sometimes you can be asked the coefficient of these groups. Can be coefficient of Fe, can be coefficient of Mn. From here, you can clearly see that the coefficient of Fe is 5. Magnesium here, sorry, manganese here is 1. H plus is 8. And water is 4. So you can be asked sometimes, or even asked the sum of everything. So guys, these are ways popular questions can come out from. These are ways they can always come out from. So guys, with this, I believe that we have been able to touch the first part of the series. I will advise us not to miss the next class for, and we're going to be taking electrode potential, chemical series, and electrolysis. So with that, we end the class here. Thanks for your time, guys. We'll see you next class.